area where you can just look at the coordinates of y mod p and y mod q. So we've got let x go to this other realm. Then we're going to have y mod p and y q goes to y is equal to x squared goes to x p y root x p x cubed squared is equal to x squared, xp squared mod p and x cubed squared mod q, which means that basically we have a relationship between yp and xp squared and yq and xq squared. So both yp and yq are quadratic residues. Okay. And then if you want to do it the reverse, you can just take it backwards. So that will just mean that if yp and yq are quadratic residues, then you're going to find that xp and xq squared will give you some xp, xq squared on the outside will lead to some number modulo n that is squared to give you some number modulo n, and that y is going to be your original y. So you have y is also quadratic residue. Yeah, and so that's basically leads us to this proposition that each quadratic residue z mod n squared, or z mod n star, has exactly 4 square roots. And do you guys know what those 4 are?
Like plus minus stuff, like the xp.
Yeah, basically you take the xp and xq, and you find plus or minus xp plus or minus xq, and just the number of combinations, so that will show you how many square roots you have. And then, once again, we have exactly 1/4 of the elements of z mod n star are quadratic residues. And you can do this math bit to show you that. Okay, this is basically one of the last things before we get into what's really interesting.
Yay!
Okay, see ya. Okay, so if we have n is equal to pq with p and q distinct odd primes, then first of all we're going to say that exactly half of the elements in z mod n star are in the numbers with Jacobi symbol +1. So there's just like these definitions. We're also going to say that the quadratic residues, mod n, are also contained in this set of numbers with Jacobi symbol +1. And then the last thing is that exactly half of the elements in this area with Jacobi symbol +1 are actually quadratic residues, and the other half are these quadratic non-residues that also have Jacobi symbol +1. So it's like a special situation.
Wait, now I'm confused.
Here's a graph. So basically, we talked about z mod p star already. So we have the quadratic residues, modulo p, half of them, and then half of them are quadratic non-residues. But if we go over here, we have 4 square roots. So it's a 4-to-1 function. So only 1 out of 4 of these numbers can actually be the quadratic residues. But we still have that half of them have Jacobi symbol +1 and half of them have Jacobi symbol -1. So what this is saying is that, first of all, half of the elements have Jacobi symbol plus 1. We'll show that. The quadratic residues all have Jacobi symbol plus 1. Yeah? And then exactly half of the elements of these Jacobi symbols with plus 1 are quadratic residues, and exactly half are quadratic non-residues.
Oh, and then you're gonna use that for probabilities.
Yeah.
Yay.
Yes. Okay. So, yeah, I'll just show it. And we'll talk about it. Okay.
We're just laughing because me and Zack are moving the camera when one of us forgets.
I see. Okay. So first, oh. So we have Jacobi symbol of x is equal to plus 1 if the Jacobi symbol